we're going to find all 6 trig functions, and it's usually going to mention that they're acute, okay, given just a point. So the point is at 4, 5. So start by drawing your x and y axis, focus mainly just on that quadrant 1. Oops, 4, 5. My comma was bad. Okay, so draw your first quadrant, and we're going to put a point P at 4, 5. So the first number is how much you go to the right. So 1, 2, 3, 4. 4 units this way. And then 5. So 1, 2, 3, 4, 5. Put a point right there. That's going to get you 5, 4. We're going to draw in the hypotenuse. Call that point P up there. And it looks like it should be a Pythagorean triple, but it's not. Okay? Because the hypotenuse should be the longest side, right? Okay? So in order to get that longest side, we have to, yes, we need to use something we learned way back in geometry called the Pythagorean Theorem. Okay? So these are our 2 legs. So we're going to say 4 squared plus 5 squared is going to be equal to x squared, c squared, whatever variable you want to use. If you want to use c, you can use c. So this is 16 plus 25. Add them together, you get 41. So x squared equals 41. And then you take the square root of both sides, and you get x equals the square root of 41. So we're going to label that hypotenuse the square root of 41. And we're going to write the 6 trig functions, okay? And the square root of 41 isn't a big deal as long as it's in the numerator. But what about when it's in the denominator? Right? Can you have a radical in your denominator? No. So when it ends up in the denominator, you're going to have to rationalize it. But if it's in the numerator, it's fine. Just leave it. No big deal. Okay? So let's start with the 3 easy ones that we learned in geometry. So we're going to say sine of theta. Okay, so let's label this theta. Cosine.
Can anyone you want be theta?
No, it needs to be very specific. And then right across from each of them, do their reciprocals. Okay, so cosecant, secant, and cotangent. All right, starting with sine. Sine is opposite over hypotenuse. So from theta, we go 5 over the square root of 41. First one is a problem, right? So we need to multiply that by what? Square root of 41 over the square root of 41, which is equal to 5 square roots of 41 over 41. And then we're good. Can't reduce 5 and 41. If you could reduce it, but you can't. Okay? Cosecant, go back to that original answer and flip it. Get its reciprocal, square root of 41 over 5. And is that one okay? Yeah, that one's fine. We don't have to do anything with it. All right, let's do cosine. Cosine should be adjacent over hypotenuse. So adjacent is 4, and hypotenuse is square root of 41. Same thing we did right here. Multiply by the square root of 41 over the square root of 41. We'll get 4 square roots of 41 over 41, and can't reduce, so we're good. For the secant, we're going to take the reciprocal, so we're going to have the square root of 41 over 4. And that one's good. We don't need to rationalize the denominator. Tangent. opposite over adjacent. So we've got 5 over 4. Yay, we're good, right? Don't no radicals, we're good. For cotangent, we just do the reciprocal, and we've got 4 over 5. Now, like I told you before, just when you're checking it, just go, okay, I need to have 2 of each, right? So I've got 5, 5, 4, 4, square root of 41, square root of 41. Should have the same over here. 5, 5, 4, 4, square root of 41, and square root of 41. All right? So just kind of check and make sure